patent clerk to physics revolutionary. Early years and the birth of a genius. On March 14, 1879, in the quiet city of Ulm, in the kingdom of Württemberg in the German Empire, a child was born who would fundamentally alter humanity's understanding of the universe. Albert Einstein entered the world with an unusually large head, causing his mother Pauline considerable worry. His grandmother, upon first seeing the infant, reportedly exclaimed, "Much too fat, much too fat." Yet this peculiar beginning would mark the start of one of history's most remarkable intellectual journeys. Einstein's father, Hermann Einstein, was an engineer and salesman who, along with his brother, ran an electrochemical factory. His mother, Pauline Koch, came from a wealthy family and was an accomplished pianist. The household was secular and culturally Jewish, though not religiously observant. This environment of intellectual freedom and cultural openness would profoundly shape young Albert's worldview. Contrary to popular myth, Einstein was not a poor student who failed mathematics. This misconception arose from confusion about the grading system used in Swiss schools. In reality, Einstein showed exceptional mathematical ability from an early age. However, he did struggle with the rigid, authoritarian educational system of late 19th century Germany. He chafed under rote memorization and preferred to explore subjects that captured his imagination. At the age of 5, Einstein experienced what he would later describe as one of the most profound moments of his childhood. His father showed him a pocket compass, and the young boy was mesmerized by the invisible forces that made the needle always point north. This simple device sparked a lifelong fascination with the hidden mechanisms of nature. He would later write that this experience produced a deep and lasting impression, and awakened in him a sense that something deeply hidden had to be behind things. When Einstein was 10, a medical student named Max Talmud began joining the family for weekly dinners, a Jewish tradition of helping poorer scholars. Talmud introduced young Albert to key texts in science, mathematics, and philosophy. Together they explored geometry, where Einstein quickly surpassed his informal tutor. By age 12, Einstein had taught himself Euclidean geometry from a textbook and began to develop his own proofs and theorems. The rebel student and Swiss education. The Einstein family moved to Munich when Albert was an infant, and then to Italy when his father's business ventures failed. 15-year-old Albert was left behind in Munich to complete his education, but he found the authoritarian school environment unbearable. He managed to obtain a medical certificate declaring him too stressed to continue, and promptly left Germany to join his family in Italy, effectively dropping out of school. This decision created a dilemma. Without a secondary school diploma, his prospects were limited. Einstein decided to apply to the prestigious Swiss Federal Polytechnic in Zurich, even though he was 2 years younger than the usual entry age. He failed the entrance examination, particularly struggling with subjects like botany, zoology, and languages. However, his exceptional performance in mathematics and physics caught the attention of the school's principal, who recommended he complete his secondary education at a school in Aarau, Switzerland. The cantonal school in Aarau proved to be a revelation. Unlike the German schools, it encouraged independent thought and visual understanding. Einstein thrived in this environment, and it was here that he began his famous thought experiments. At 16, he imagined what it would be like to ride alongside a beam of light. If you could travel at the speed of light, he wondered, would the light wave appear stationary relative to you? This seemingly simple question would occupy his mind for years, and eventually lead to the theory of special relativity. Einstein graduated from Aarau in 1896 and was finally admitted to the Polytechnic in Zurich. He studied to become a teacher of physics and mathematics, but once again found himself at odds with academic convention. He often skipped lectures, preferring to study on his own or spend time in the laboratory. His independent streak did not endear him to his professors, particularly Heinrich Weber, who grew frustrated with Einstein's casual attitude toward formal education. During his time at the Polytechnic, Einstein fell in love with Milva Maric, the only woman in his physics class. She was Serbian, brilliant, and shared his passion for physics. Their relationship was intellectual as well as romantic, and they spent countless hours discussing physics and philosophy. However, Einstein's mother strongly disapproved of Milva, considering her too old, too intellectual, and an unsuitable match for her son. The patent office years. Genius in isolation. When Einstein graduated in 1900, he hoped to secure a position as a university assistant, the traditional path to an academic career. However, his mediocre grades and poor relationships with his professors meant that no offers were forthcoming. For 2 years, he struggled to find stable employment, taking temporary teaching positions and even considering selling insurance. In 1902, with the help of a friend's father, Einstein secured a position at the Swiss Patent Office in Bern as a technical expert, third class. This seemingly mundane job would prove to be a blessing in disguise. The work required him to evaluate patent applications for electromagnetic devices, which kept his mind engaged with practical physics problems. More importantly, once he completed his daily duties, he had time to pursue his own theoretical investigations. Einstein later called the patent office his worldly cloister, a place where he could think about physics without the pressure and politics of academia. He would work on patents during the day and dedicate his free time to solving the deepest problems in physics. In his small apartment, often while rocking his infant son Hans Albert in a cradle with one hand, he would fill notebooks with calculations that would revolutionize science. The early 1900s were a tumultuous time in Einstein's personal life. In 1902, his father died, and on his deathbed, he finally gave his blessing for Albert to marry Milva. They married in January 1903. Before their marriage, Milva had given birth to a daughter, Lieserl, whose fate remains one of history's mysteries. The child was likely given up for adoption or died in infancy, and Einstein may never have met her. Despite personal challenges, Einstein's scientific productivity during this period was extraordinary. He was tackling some of the most fundamental questions in physics. How do molecules move in liquids? How does light interact with matter? What is the nature of space and time? He worked in almost complete isolation from the academic community, unaware of some related work and unburdened by conventional thinking. The miracle year, 1905. The year 1905 would become known as Einstein's annus mirabilis, or miracle year. In the span of just a few months, while working full-time at the patent office and caring for his young family, Einstein published 4 papers in the prestigious German journal Annalen der Physik. Each paper was revolutionary in its own right, and together they would transform physics. The first paper, published in March, proposed that light could be understood as consisting of discrete packets of energy, which we now call photons. This was a radical idea because it challenged the wave theory of light that had dominated physics for a century. Einstein used this particle model to explain the photoelectric effect, a phenomenon where light hitting certain materials causes them to emit electrons. Classical wave theory couldn't explain why the energy of the emitted electrons depended on the frequency of light rather than its intensity. Einstein's quantum explanation was so revolutionary that it would earn him the Nobel Prize 16 years later. The second paper, completed in April, was Einstein's doctoral dissertation on a new method of determining molecular dimensions. While less famous than his other work, this paper was actually his most cited during his lifetime and had practical applications in chemistry and industry. The third paper, published in May, explained Brownian motion, the random jittering of microscopic particles suspended in a fluid. Scientists had observed this phenomenon for decades but couldn't explain it. Einstein showed that this motion was caused by collisions with individual molecules of the fluid, too small to see but whose collective effect was visible. This paper provided some of the most convincing evidence for the atomic theory of matter, which some prominent scientists still doubted at the time. The fourth paper, received by the journal in June, introduced the special theory of relativity. Einstein showed that the speed of light is constant for all observers, regardless of their motion. This simple postulate had profound consequences. Space and time are not absolute but relative to the observer's motion. Two events that appear simultaneous to one observer might occur at different times for another observer moving at a different velocity. The familiar concepts of length and duration become flexible, depending on one's frame of reference. In September, Einstein published a brief follow-up to his relativity paper that contained perhaps the most famous equation in all of science, E equals mc2. This deceptively simple formula revealed that mass and energy are interchangeable, that a small amount of mass could be converted into an enormous amount of energy. Though Einstein didn't realize it at the time, this equation would eventually explain the power of the sun, and decades later, lead to both nuclear energy and nuclear weapons. Recognition and academic ascent. Despite the groundbreaking nature of his 1905 papers, recognition came slowly. The scientific community needed time to digest these revolutionary ideas, and Einstein was still an unknown patent clerk. However, gradually, leading physicists began to take notice. Max Planck, one of the founders of quantum theory, was among the first to recognize the importance of Einstein's work on relativity. In 1908, Einstein finally received his first academic appointment as a lecturer at the University of Bern, though he had to keep his patent office job to support his family. The following year, he was appointed associate professor at the University of Zurich, allowing him to leave the patent office after 7 productive years. Academic positions at the University of Prague and back at the Zurich Polytechnic, now renamed ETH Zurich, followed in quick succession. During these years, Einstein continued to develop his theories and engage with the growing community of physicists working on quantum theory and relativity. He became a regular participant in scientific conferences and began to build relationships with other leading scientists. Yet he remained somewhat of an outsider, uncomfortable with academic politics and formal hierarchies. Einstein's marriage to Malva was deteriorating. The couple had a second son, Eduard, in 1910, but their relationship grew increasingly strained. Malva resented the time Einstein devoted to physics, and Einstein found her increasingly melancholic and difficult. The intellectual partnership they once shared had faded, and their personal relationship suffered as Einstein's fame grew. The quest for general relativity. While Einstein's special relativity explained motion at constant velocities, it couldn't handle acceleration or gravity. Einstein realized this limitation almost immediately and began working on a more general theory. This quest would consume him for nearly a decade and push his mathematical abilities to their limits. The key insight came to Einstein in 1907 while still at the patent office. He imagined a person falling from a roof. During the fall, the person wouldn't feel their own weight. They would be weightless, just like an astronaut in orbit. Einstein called this the happiest thought of my life. It suggested to him that gravity and acceleration were somehow equivalent, a principle he called the equivalence principle. If gravity and acceleration were equivalent, then gravity should affect light just as acceleration does. A beam of light in an accelerating elevator would appear to curve. By the equivalence principle, light should also curve in a gravitational field. But in special relativity, light travels in straight lines through flat spacetime. If gravity could curve the path of light, then gravity must be curving spacetime itself. This realization led Einstein to a radical conclusion. Gravity is not a force, as Newton had described it, but rather a curvature of spacetime caused by mass and energy. Massive objects like the Sun create a depression in the fabric of spacetime, and planets orbit not because they're pulled by a mysterious force, but because they're following the curved contours of spacetime, like marbles rolling in a bowl. Translating this physical insight into precise mathematics proved extraordinarily difficult. Einstein had to master branches of mathematics, particularly differential geometry, that were unfamiliar to most physicists at the time. He collaborated with his old classmate Marcel Grossmann, who helped him navigate the complex mathematics developed by Bernhard Riemann and others. The work was mentally exhausting. Einstein made several false starts, publishing incomplete versions of the theory only to find errors and contradictions. In 1913 and 1914, he came tantalizingly close but made mistakes that delayed the final breakthrough. The pressure was intense, made worse by the knowledge that the brilliant mathematician David Hilbert was working on similar problems and might publish first. Triumph in turmoil. In November 1915, Einstein finally completed the general theory of relativity. In a series of lectures to the Prussian Academy of Sciences in Berlin, he presented the field equations that describe how matter and energy curve spacetime, and how this curvature determines the motion of matter and energy. The equations were beautiful, elegant, and unlike anything in physics before them. Einstein immediately applied his new theory to a long-standing puzzle in astronomy, the peculiar orbit of Mercury. The planet's elliptical orbit slowly rotates over time, and Newton's gravity couldn't fully explain this precession. Einstein's general relativity predicted exactly the observed effect. When his calculations matched the astronomical data perfectly, Einstein later said he felt as if something actually snapped inside him, so powerful was his sense of achievement. But general relativity made an even bolder prediction that could be tested. The theory predicted that starlight passing near the sun would be deflected by an amount twice as large as Newtonian physics would suggest. During a total solar eclipse, when stars near the sun become visible, this deflection could be measured. Einstein would have to wait for the opportunity to test this prediction. Personally, these were difficult years. Einstein had moved to Berlin in 1914, and Malva initially came with him and their sons. However, the marriage was beyond repair. Malva soon returned to Zurich with the children, and the couple formally separated. Einstein began a relationship with his cousin Elsa, whom he would later marry. World War I broke out shortly after Einstein arrived in Berlin, and he was horrified by the nationalism and militarism that gripped Europe. While many German scientists signed a manifesto supporting the German war effort, Einstein was one of only 4 academics to sign a counter-manifesto promoting pacifism and international cooperation. This position made him unpopular with German nationalists, but Einstein never wavered in his opposition to war. Global fame. The war prevented immediate testing of general relativity's predictions about light deflection, as astronomical observations required international cooperation. However, British astronomer Arthur Eddington was intrigued by Einstein's theory and determined to test it despite the war. In 1919, with the war finally over, Eddington led expeditions to observe a total solar eclipse from 2 locations, Sobral in Brazil and Principe, an island off the coast of West Africa. The results, announced in November 1919, confirmed Einstein's predictions. Starlight had been deflected by the sun's gravity, and by approximately the amount Einstein's theory predicted. The announcement made headlines around the world. The Times of London proclaimed revolution in science and Newtonian ideas overthrown. Almost overnight, Einstein became the world's most famous scientist. The timing was significant. World War I had just ended, and a British expedition confirming the theory of a German scientist seemed to symbolize the transcendence of science over national boundaries. Einstein became not just a scientific celebrity, but a symbol of international cooperation and human reason. Photographs of the wild-haired professor appeared in newspapers everywhere, and his name became synonymous with genius. Einstein was simultaneously fascinated and dismayed by his celebrity. He gave lectures to packed audiences, attended countless social functions, and received thousands of letters from admirers, cranks, and people seeking his help. He used his fame to advocate for causes he believed in: pacifism, Zionism, civil rights, and international cooperation. Yet he often longed for the quiet days in the patent office, when he could think about physics without constant interruption. The 1920s brought both triumph and challenge. In 1921, Einstein received the Nobel Prize in Physics, though notably not for relativity, which was still considered controversial by some, but for his explanation of the photoelectric effect. He embarked on international tour, visiting the United States, Japan, Palestine, and other countries, greeted everywhere as a hero and sage. However, in Germany, Einstein faced growing hostility. Anti-Semitism was rising, and some German physicists, motivated by both scientific skepticism and racial prejudice, attacked relativity as Jewish physics. Einstein received death threats, and one anti-relativity propagandist was connected to the assassination of Germany's foreign minister. Einstein seriously considered leaving Germany, but colleagues convinced him to stay. The quantum debates. While Einstein's work had helped birth quantum theory with his 1905 paper on the photoelectric effect, he became increasingly uncomfortable with the direction quantum mechanics took in the 1920s. Young physicists like Werner Heisenberg, Niels Bohr, and Max Born developed a new quantum mechanics that was extraordinarily successful at predicting experimental results, but seemed to suggest that reality at the atomic level was fundamentally probabilistic and uncertain. Einstein couldn't accept this interpretation. He believed that physics should describe an objective reality that exists independent of observation. He famously declared, "God does not play dice with the universe," expressing his conviction that the apparent randomness of quantum mechanics must reflect our incomplete understanding, not a fundamental feature of nature. There must be hidden variables, he argued, that would restore determinism and objectivity to physics. The debates between Einstein and Bohr at scientific conferences became legendary. Einstein would propose thought experiments designed to show contradictions or absurdities in quantum mechanics, and Bohr would spend sleepless nights finding the flaws in Einstein's arguments. These exchanges, conducted with mutual respect despite profound disagreement, represent one of the great intellectual confrontations in the history of science. In 1935, Einstein, along with Boris Podolsky and Nathan Rosen, published a paper arguing that quantum mechanics must be incomplete. The EPR paradox, as it became known, described a situation where quantum mechanics seemed to require spooky action at a distance, instantaneous influences between distant particles. Einstein considered this absurd and concluded that quantum mechanics couldn't be the final word on atomic reality. Ironically, modern experiments have confirmed that nature does exhibit the spooky correlations Einstein found so troubling, though they don't allow faster-than-light communication. Most physicists today accept quantum mechanics as fundamentally correct, though Einstein's objections sparked important work on the foundations of quantum theory and led to practical applications like quantum cryptography and quantum computing. Escape from Nazi Germany. Einstein's worst fears about Germany were realized when Adolf Hitler came to power in January 1933. Einstein was visiting the United States at the time and immediately declared he would not return to Germany. The Nazi regime confiscated his property, revoked his citizenship, and put a bounty on his head. His books were burned, and his position at the Prussian Academy was given to someone more politically acceptable. Einstein settled permanently in the United States, accepting a position at the newly created Institute for Advanced Study in Princeton, New Jersey. Princeton would be his home for the remaining 22 years of his life. He became an American citizen in 1940, adding to his Swiss citizenship, which he had maintained since 1901. The 1930s and 1940s were heartbreaking years for Einstein personally. His younger son Eduard suffered from schizophrenia and spent much of his life in psychiatric institutions. Einstein's relationship with his older son Hans Albert was strained. His beloved younger sister Maja came to live with him in Princeton after fleeing Italy, but she suffered a stroke and was bedridden for years before her death. During these years, Einstein worked on his unified field theory, attempting to merge gravity and electromagnetism into a single framework. He hoped to extend general relativity to incorporate all the forces of nature and perhaps provide an alternative to quantum mechanics. Despite decades of effort, this quest proved elusive. Unlike his earlier work, which had been guided by clear physical principles and experimental puzzles, the unified field theory lacked both. Meanwhile, the world moved on. Younger physicists explored quantum field theory, nuclear physics, and particle physics, areas where Einstein's contributions were minimal. Some saw Einstein as a relic, stubbornly pursuing an obsolete program while the real action happened elsewhere. Yet Einstein remained confident in his approach, believing that a truly fundamental theory must be deterministic and unified. The atomic age and its moral dilemmas. In 1939, Einstein faced a profound moral dilemma. Physicists Leo Szilard and Eugene Wigner, fellow refugees from Europe, brought Einstein troubling news. Recent experiments had demonstrated nuclear fission, the splitting of uranium atoms, and it was theoretically possible to create a devastating chain reaction. They feared Nazi Germany might develop an atomic bomb. After much deliberation, Einstein agreed to sign a letter to President Franklin Roosevelt, drafted by Szilard, alerting him to this danger and recommending that the United States pursue nuclear research. This letter helped prompt the Manhattan Project, though Einstein himself played no role in developing the atomic bomb. His famous equation E equals mc2 explained the enormous energy that nuclear weapons could release, but Einstein had not foreseen this application. When atomic bombs destroyed Hiroshima and Nagasaki in August 1945, Einstein was horrified. He later called his letter to Roosevelt the one great mistake in my life, though historians debate whether the letter significantly influenced the decision to build the bomb. In the post-war years, Einstein became a passionate advocate for nuclear disarmament and international control of atomic weapons. Einstein worked with other scientists to found the Emergency Committee of Atomic Scientists, campaigning for peaceful uses of nuclear energy and warning against nuclear arms races. He advocated for world government as the only way to prevent nuclear war, arguing that national sovereignty was obsolete in the atomic age. These views were controversial during the early Cold War, and FBI Director J. Edgar Hoover kept a massive file on Einstein, suspecting him of communist sympathies. Final years and enduring legacy. In his final years, Einstein remained active intellectually despite declining health. He continued his work on unified field theory, maintained an enormous correspondence, and spoke out on political issues. He was offered the presidency of Israel in 1952, following the death of Israel's first president, Chaim Weizmann. Einstein politely declined, saying he lacked the natural aptitude and experience for dealing with people. Einstein's last public act was signing a manifesto with philosopher Bertrand Russell, calling on world leaders to renounce nuclear weapons and find peaceful means of resolving conflicts. The Russell-Einstein Manifesto, issued just days before Einstein's death, led to the Pugwash Conferences on Science and World Affairs, bringing together scientists from around the world to work for disarmament. On April 18, 1955, Einstein died at Princeton Hospital from an abdominal aortic aneurysm. He was 76 years old. True to his lifelong desire to avoid personality cults, he had requested no funeral ceremony, no grave, and no monument. His body was cremated, and his ashes scattered in an undisclosed location. Only his brain was preserved, controversially, without family permission initially for scientific study. Einstein's scientific legacy is almost impossible to overstate. Special relativity revolutionized our understanding of space, time, and motion. General relativity provided a new theory of gravity that describes the universe on the largest scales, from the orbit of Mercury to the expansion of the cosmos itself. Modern technologies from GPS satellites to particle accelerators rely on relativistic physics. His work on the photoelectric effect helped establish quantum theory, even though he later questioned where that theory led. His explanations of Brownian motion helped confirm the reality of atoms. His equation E equals mc2 reveals the equivalence of mass and energy, underlying both the power of stars and the devastating potential of nuclear weapons. Beyond his scientific achievements, Einstein became a cultural icon representing the power of human intellect. His image, the wild hair, the thoughtful gaze, the rumpled sweater, is instantly recognizable worldwide. Einstein became a synonym for genius, his name invoked whenever exceptional intelligence needs to be described. Yet Einstein, the man, was more complex than the saint-like figure of popular imagination. He was a loving father to some children and distant to others. He was a passionate advocate for social justice who could also be thoughtless in personal relationships. He was a genius who revolutionized physics but spent the last decades of his life pursuing a theory most physicists thought was misguided. The Einstein paradox. Perhaps the most fascinating aspect of Einstein's life is the paradox at its center. He was a revolutionary who overthrew Newtonian physics but spent his later years as a conservative, resisting the quantum revolution. He was a pacifist whose equation explained nuclear weapons. He was a man who valued solitude and contemplation, but became the world's most famous scientist. He advocated for social justice and human rights while struggling in his own personal relationships. Einstein once said, "The important thing is not to stop questioning. Curiosity has its own reason for existing." His life embodied this principle. From the compass that fascinated him as a child to his final equations scribbled days before his death, Einstein never stopped questioning, never stopped trying to understand the universe's deepest mysteries. His thought experiments, riding a light beam, falling in an elevator, twins separated at birth traveling at different speeds, showed that profound physics could emerge from pure thought, guided by imagination and physical intuition. He demonstrated that creativity and imagination are as essential to physics as mathematics and experiment. Einstein also showed that science and moral conscience need not be separate. He used his fame to advance causes he believed in: peace, social justice, civil rights, and international cooperation. When Princeton's Nassau Inn refused to host the Nobel Prize-winning black singer Marian Anderson because of racial segregation, Einstein invited her to stay at his home, and they became friends. He corresponded with W.E.B. Du Bois and spoke out against racism in America, calling it a disease of white people. Conclusion: a light that still shines. Nearly 70 years after his death, Einstein's influence remains profound. Gravitational waves, predicted by general relativity, were first detected in 2015, confirming yet another of Einstein's insights. The Event Horizon Telescope's 2019 image of a black hole's shadow showed general relativity working under the most extreme conditions. Quantum entanglement, which Einstein skeptically called spooky action at a distance, now forms the basis of emerging quantum technologies. Einstein's life reminds us that scientific progress requires both imagination and rigor, both creativity and discipline. It shows us that the greatest scientists are those who dare to question the most basic assumptions, who trust their physical intuition even when it contradicts common sense, who persist despite setbacks and criticism. But perhaps Einstein's most important legacy is his demonstration that a single human mind, armed with nothing more than thought experiments, mathematical tools, and deep physical intuition, can unlock secrets of the universe that had been hidden since the beginning of time. From a patent office in Bern, an unknown clerk reimagined the nature of space, time, matter, and energy. That achievement stands as a testament to human potential and the power of ideas. Albert Einstein was not just a physicist who discovered some equations. He was a visionary who saw deeper into the nature of reality than almost anyone before or since. He was a humanitarian who believed science should serve humanity. He was a symbol of intellectual courage, forever young in his curiosity, forever willing to question, forever reaching for understanding. In his own words, the most beautiful experience we can have is the mysterious. It is the fundamental emotion that stands at the cradle of true art and true science. Einstein's life was devoted to exploring that mystery, and through his work, he invited all of humanity to join him in that exploration. That invitation remains open, and the light of his genius continues to illuminate our path toward understanding.